Hello, today we will study this classification of polymers. The polymers are classified into six different ways, six different types. First type is based on source or origin. Second type is based on structure. Third type of classification is based on intermolecular forces. Fourth type is based on mode of polymerization. Fifth type is on the basis of number of monomers. And sixth type is biodegradability. So we will study all types of this classification one by one in detail. So the first type is classification of polymers on the basis of source or origin. So on the basis of origin, these polymers are classified into three categories. One is a natural, second is a synthetic, and third type is semi-synthetic polymers. So on the basis of source or the origin, polymers are classified into three types. These are natural, synthetic, and semi-synthetic polymers. First is natural polymers. The polymers obtained from natural source are called natural polymers. They are further subdivided into two types. So naturally we get polymers from plants and animals. Accordingly, these polymers are called as a plant polymers. Plant polymers are also called as a vegetable polymers. Now, what are these plant polymers? They are obtained from plants. For example, cotton, linen, and jute. This cotton is obtained from cotton plant and linen is obtained from flax plant. Natural rubber is another example of natural polymer, which is manufactured from latex obtained from the bark of rubber trees. So that is the plant polymers or vegetable polymers. Second type under natural polymers is animal polymers. So some polymers they are obtained from animal source and the examples are wool and silk. So wool is obtained from sheep and silk is obtained from silkworm. So that is about the plant and the animal polymers. The second type is a synthetic polymers. These are also called as a man-made polymers. These are artificially prepared by polymerization of one monomer or by copolymerization of two or more monomers. Examples of synthetic polymers are nylon, terylene, neoprene. These are the examples of synthetic polymers. The, these are further divided into namely fibers, synthetic rubbers, and plastic that we will study in the next part of this chapter. Next type is a semi-synthetic polymers. This third type is based on origin or the source. So these are derived from natural polymers, that is due to chemical action on the natural polymers, the fibers or the polymers obtained they are called as a semi-synthetic polymers. They are also called as a regenerated fibers. Cellulose derivatives like cellulose acetate rayon, then cellulose nitrate, viscous rayon, cupra ammonium rayon. These are the examples of semi-synthetic polymers. Then semi-synthetic polymers, they are used in the preparation of non-inflammable photographic films, cinema films, and varnish. So that is about the first type of polymers. They are the classification on the basis of origin or the source. The second type of classification of polymers, it is classification based on their structure. So on the basis of structure, these polymers are classified again into three types. That is linear polymers, branched chain polymers, and cross-linked polymers. These three types are on the basis of structure, linear, branched, and cross-linked polymers. Depending upon how monomers are linked together, that is the chain configuration, these polymers are classified into three types, that is a linear, branched, and three-dimensional cross-linked polymers. These structures are given in the figure 15.1. This A figure shows these are linear polymers. In the B figure, they are branched, and in the C figure, it is cross-linked polymers. The name of linking polymers depend upon the nature and the number of functional groups present in the chain. So the first type is linear polymer, or they are also called as straight chain polymers. When monomer molecules are joined together in a linear arrangement or the straight chain arrangement, which resulting a polymer, a straight chain polymer, it is obtained from bifunctional monomers or alkenes. Example of this type is a PVC. PVC means polyvinyl chloride. Or other example is high density polymer, means HDP. Second type is branched chain polymer. So this is the second most common arrangement, that is a branched chain, monomer having three functional groups or already having the side chain, which gives rise to branched chain polymers. And they are the examples is a low density polymer. In the first type, we had studied high density polymer. Now it is a low density polymer. Then third type under this is a cross-linked polymer. So in this type, the arrangement is cross-linked, or the network type of polymer. They are produced between the linear chains. The cross-linking results from the polyfunctional monomers. And example of this type is bakelite, melamine. These are the examples. So that is the second type of classification of polymers on the basis of structure. Then third type is classification of polymers on the basis of mode of polymerization. The polymerization is the fundamental process by which the low molecular compounds are converted into high molecular compounds by linking together of repeating structural units with covalent bonds. This process of polymerization is explained here with general equation. Here the low molecular mass material, that is a process reactive groups under high temperature or pressure or catalyst converted into high molecular mass material, and that is called as a polymer. The three modes of polymerization according to the type of reactions taking place between monomers. These are addition polymerization, also called as a chain growth polymerization. Second type is a condensation polymerization, also called as a step growth polymerization. And third is a ring opening polymerization. So these are three modes of polymerization: addition, condensation, and ring opening. First is addition polymerization. What is addition polymerization? In this process, the formation of polymers by addition of monomers without loss of any small molecules, just these monomers join together, repeating unit take place, and addition has the same elemental composition present in the original monomer. Compounds containing double bonds undergo this type of addition polymerization. So which compound undergo addition polymerization? Which containing double bond. They are also called as a vinyl polymerization, because the vinyl category that is coming under this type. Vinyl chloride is CH2 double bond CHCl, or acrylonitrile is CH2 double bond CHCN. The formation of polyethylene from ethylene is also well-known example of addition polymerization type. Addition polymerization produce high molecular mass polymeric material without formation of intermediate low molecular mass polymeric material. The free radical mechanism is the most common example of addition polymerization. It is also called as chain reaction, and which involves the three steps. We know free radical reaction involves chain initiation, chain propagation, and chain termination step. So first step is chain initiation. In the chain initiation, the from the molecule by breaking bond by homolytic fission, one electron goes to one, this radical is formed, free radical is formed. For example, benzoyl peroxide, acetyl peroxide, tertiary butyl peroxide. These are used for producing free radical. Here, example of acetyl peroxide is used. We know acetyl group is CH3CO. When it is bonded with O single bond O, again CO double bond CH3. This is called as acetyl peroxide. The bond between oxygen and oxygen breaks homolytically, means the two electrons present between oxygen-oxygen bond get divided symmetrically and the radical is formed. This radical is called as a acetyl free radical. It is unstable. It immediately loses CO2 molecule and methyl free radical is formed. In short, it is called as a alkyl free radical. So this get attached with olefin. Olefin means alkene. Here vinyl monomer, and produce a new radical which is made up of two parts, namely attached radical and the monomer unit. Here this reaction is shown. This is R means alkyl free radical get bonded with vinyl monomer. Here breaking of double bond take place with homolytic bond fission. Only one bond breaks and new radical is formed. In the second step, chain propagation, this new radical again react with one more vinyl monomer and the chain growth take place, the sequence repeated and the bigger sized radical is formed. So one monomer is converted into another monomer with radical. This is called as a chain propagation step. Then in the third step, that is called as a chain termination step, this many radicals join together to form a long chain compound that is called as a polymer. Here R CH2CHY N times CH2CH radical Y. These two radicals join together to form a long chain compound that is called as a polymer. So that is the first type called as a free radical type of mechanism or called as a addition polymerization. Second type is condensation polymerization. In the condensation polymerization, we will consider this terylene preparation. It is a type of polyester type of polymer. Monomers are ethylene glycol and terephthalic acid. The reaction is OH CH2CH2OH is ethylene glycol N times plus COH COH at para position of benzene. This is called as a terephthalic acid. Here N molecules, here minus N times H2O are lost. We get CH2 CH2O C double bond O benzene ring N times COOH. This COO linkage is called as a ester linkage. This is a terylene polymer or the Dacron polymer. This is a condensation polymer. In this polymerization, two large molecules are joined together by the loss of small molecule like water. The process of formation of polymers take place from the polyfunctional monomers by elimination of small molecules of like water or hydrochloric acid or methanol or ammonia. This is called as a condensation polymerization. This is also called as a step growth polymerization. And step growth polymerization that gives high molecular mass polymer. Then third type of polymerization that is called as a ring opening type of polymerization. Here the example is given, that is preparation of nylon 6. It is a third type of polymerization, the ring opening polymerization. The cyclic compound like lactams or cyclic ethers or lactones, they polymerize and ring opening take place by using strong acid or base or catalyzes the reaction. And here the example is given as a epsilon caprolactam. Here CO bonded with CH2, 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 CH2 5 times and then NH. Here CO CH2 5 times NH. This is called as a epsilon caprolactam. Alpha carbon, beta carbon, gamma, delta and epsilon. Here the breaking of this ring take place and give NH 5 times CO N times, this is nylon 6. The elemental composition of the repeating unit in the polymer resulting from the ring opening polymerization is the same as that of monomers. as in case of addition polymerization. Addition polymerization are often very rapid, but ring opening aids a ring opening polymerization proceed by addition of single monomer unit but never of large units to growing chain molecules. In this case, the ring opening polymerization is a step growth polymerization similar to condensation polymerization. So these are the three types of polymerization, that is addition, then condensation and ring opening type of polymerization. So that is about the first three types or the three ways of classification of polymers. We had studied three ways of classification, that is on the basis of, first is on the basis of source or origin, second is on the basis of structure, and third is on the basis of polymerization. So on the basis of source, we had studied natural polymers, then synthetic polymers and semi-synthetic polymers. On the basis of structure, we had studied linear, then branched and cross-linked type of polymers. On the basis of mode of polymerization, three types: addition, condensation, and and third type is ring opening type of polymerization. These three ways of classification we had studied. Other three ways of classification we will study in the next lecture. Thank you.